Welcome everybody. Today I'm going to talk about the Menger Sponge. This is a fractal that is based on a cube. You can read about it on Wikipedia, and these are the main forms of it that you see below. This fits into a theme of a game that I've been working on recently. So I'm going to show you what I did and some of my adventures with the Menger Sponge, both in Unreal Engine and then ultimately in Blender and then back to Unreal Engine. So let's get started. Okay, the very first thing that I did is I'm going to show you how I built a Menger Sponge using nothing but blueprints. And I ended up replacing this mechanism with just a static mesh that I created in Blender. And so I have some other video that I took earlier, but I'm going to show you the blueprint layout that I did so that if you were interested in doing this or recreating it or using it for something else, you could do that. So the basic mechanics of it is I created a blueprint based off of an actor. I created a hierarchical instant static mesh. On the begin play, I called the rebuild function. I'll show you what that does. And then here I'm just setting a rotation for the rotating movement. The rebuild function kind of sets up the hierarchical static mesh and gets ready for building. And then every tick, I was processing a set of pending items that needed to be processed. So let's look at the rebuild function. And I will overlay some of the video that I took earlier of this getting built. But basically, the way the rebuild function works is I had a list of pending cube info structures, and I would clear that out. I would then make sure that I had a mesh. I would clear all the instances from the hierarchy. I would set the static mesh and the material for the hierarchy. This code here about the bounds and the number of levels had to do with how I am breaking down the cube. And I will show you, once we look at the picture again, I'll show you exactly what the logic is doing here. But if you want to create it, you can do it here. So I set the scale of my instance. I'll show you what that means. And then ultimately, I create the very first pending cube that we are going to process. And so the cube is based off the width that I want, and the origin is at the center of the blueprint. And then I enable the actor tick. So once tick gets processed, I would have this like this, right? And then in the process pending function, what I would do is, the way this works is that this for loop is just an iterator. So I would process 8 items at a time every tick. I did that just to speed things up a little bit. But what I would do is I would say if I have any pending cube info items to process, and then what I would do is I would remove the last one, grab the last cube info item, store that, and then I would call this subdivide function. And what subdivide is doing is when you're looking at your cube here, if you start with this cube right here, and if you subdivide it, you're going to convert a single cube like this into a Rubik's cube, right? So it's 3 across, 3 down, and 3 deep. You're going to convert those 21 cube into 27 cubes. And then with a Menger sponge, you remove the very center cube and the 6 cubes on each of the centers of the faces. So if you keep doing this, this is what a Menger sponge is, right? So this logic that I had, this subdivide, we go back and look at this subdivide function. What it's doing in a blueprint is basically what I just described to you. It's taking the width, dividing it by 3, because remember, Rubik's Cube, 3 across, 3 down, 3 deep. Then for each of those items, what I do is, this is a for loop from -1 to 1 for the X, Y, and Z. So if you do that for loop, what you can do is multiply the X, Y, and Z values by the width of the cube of the child, right? So if you take your main cube, divide it by 3, that's going to be the width of the child. And then if you add those offsets, so for example, -1 times the width would be like -1 times 50. You know, for example, if the child size is 50, if you add that to the current X, this is going to give you the positions of all the child cubes within a cube that has been subdivided. So you could end up with a possibly 27 cube locations, right? But because we get rid of the center faces, I have some logic right here that checks to see if the X and Y, the Y and Z, or the X and Z, if those are both equal to 0, that is a center face, and the very center of the cube. So if any of those are, assuming it's not a center face, we add it to our children, right? And then at the very end of our routine here, we loop through the children, and I create, this is just creating the structure that I use to store this. So I store the iteration of how deep I am. So this is kind of like a recursive thing. So the deeper you go, I keep storing the next level down. And then at the very end, I add it to my results, and then we return our results at the very completion. So going back to our process pending, we subdivide our cube, we iterate through the children, and then if we are at the level of the cube, the Menger sponge that we want to be at, then I go ahead and add the instance. Otherwise, I add it to my pending list, and it will keep getting broken down smaller and smaller and smaller. So the reality is, let's go back to our, so these are the levels, right? These are the levels of a cube. So this is level 0, this is level 1, level 2, level 3. And if you keep going down, you end up with a lot of little tiny cubes making all of these up. So what I do for each of these cubes is I add them to a hierarchical instant static mesh, and that's how I was creating my Menger sponge. The problem with this is you very quickly end up with a lot of instances within your Menger sponge, and because of that, it will drag your FPS way down. So for like a level 4 or 5, you end up with, I think level 4 was around 8,000 cube instances. And level 5, I don't think I ever even processed level 5 because it just couldn't handle it. So what I ended up doing was I ended up converting the logic that I created in this blueprint, okay, which I believe I've shown you everything at this point. So I just want to make sure you can pause. You can pause if you want to recreate this, but this ultimately will not work for you if you do a really deep sponge, but you could use the same logic for other things. Here's the subdivide function. Let me just show you that one more time. All right. So, yeah, I think you got enough there. Anyway, I wouldn't recommend doing this. It's not very efficient. For small things, it works. But the better way that I found was to recreate this logic in Blender, generate a static mesh, and then import the mesh. So let's flip over to Blender, and then I will show you how I did that. All right, so let me show you exactly how I did this. And this is the really the important thing. I did this by creating a script. So in Blender 2.8, if you go to the scripting tab, you can write Python code. And with this Python code, you can interact with Blender, using the API. And by doing that, you can really implement anything that you want. And this is a most basic example, but it does implement the Menger cube algorithm, okay? Or at least how I implemented it anyway. So let me just run through this very quickly, and I'll show you how to do it. If you have questions, leave me a comment below. So we import the BPY. These are things related to Blender. And we also import the vector from math-utils. I'm not sure I actually needed this, but I'm not very good at this, so this is how I did it. I created a class in Python. I called it CubeInfo, and it has a vector, it has a depth and a width. I created a function called subdivide, which you pass in a cube, and the cube is of type CubeInfo. The way this works is the subdivide function, you give it a cube, and it will subdivide it into the 27 cubes, the 3 across, 3 down, 3 deep, but it will remove the center cubes to give you the Menger sponge. So by doing that, you'll notice this right here is the same logic where I was walking through -1 to 1, but in this Python code, though, the range function, you have to go 1 beyond that. So it's -1 to 2. So this 3 for loops will generate the x, y, and z. We multiply it by the width and add it to the origin of the current cube. We then calculate if this is a center or not using the x and y and z coordinates, seeing if there's 0. And if it's not a center piece, then we create a new CubeInfo object. We set the origin, the depth is the current depth plus 1. And we set the width, which is the width of the child that we created by taking the width of the current cube and dividing it by 3. We append those to the child to the results, and then we return them. So this whole logic then, the next part is we create a mesh. This is the main part of the script. So now our function is finished up here. So that's our function. Here's the start of our script. I create a new mesh. I add the Menger, I add a new object, the Menger Sponge, and to the mesh, which gives us my object. I set the location of the object, and then I link it to the collections, so that it will like show up over here, right? So over on the right side under our collection. So this is the base collection. The next thing I do is I set the object to the active object, and I change it to edit mode. So that would be the same as like hitting tab. I set my depth to 2, cube info. So this is my starting cube, and I keep looping through the cube array as long as it has items in it. And inside my while loop, I pop off the first item, I subdivide it, and then for each of the children, if we've reached the final depth that I'm looking for, so depth meaning the number of times we've recursed into the cube, then I will add that primitive to the mesh that I'm currently editing. Otherwise, I just append it to be processed again and subdivided. So once you loop through all of those and you've completed your iterations, which if you have a very high depth, so you really can't go beyond 4 here. That will bring your computer to its knees. So really you can do 2 or 3. That's about the most you can do. So at the very end, I set the mode of the object back to object. So in order to see this in action, we just look over here. All I need to do is run my script. So you just punch in this script, hit run, and boom, here is my new object that I created. So this is a Menger Sponge that is a 2 by, that's 2 deep, right? So that is this sponge right, hold up. Yep. So that is this one right here. So this is 0, this is 1, this is 2. So this is the sponge that we have. Now, if you took this cube here and you see, if you look at just this corner cube here, if you created an array of these and added them together, what you can do is you can create the next level down. So if I take this 2, merge them together into this structure, you'll get a 3. And then you could keep going down to a 4 and a 5. So that is what I'm going to do now. Okay, everybody, I am going to show you the entire process for creating the Menger Sponge. And I used 2 mechanisms here. So the first is we're going to run our script. We already went through that. So when I run the script, it's going to generate our Menger Sponge right here. But now what I'm going to do is I'm going to scale this up. Instead of being a level 2 Menger Sponge, right? So instead of being this sponge here, it's going to be this sponge right here. So it's going to go to a level 3. So going back to here, the first thing we're going to do is we're going to create 3 array modifiers. So array, array, array. We're going to set the count to 3 on the first one, and we're going to leave the relative offset x. We're going to set it to 3 on the next one, and we're going to change the relative offset to y. So we set that to 1. The last one, we're going to set it to 3. And then we're going to change the relative offset to the z-axis, which makes it nice and tall like that. So now we have our cube. Let me get this out of here. Now that we have this cube here, we need to cut the middle parts out. And that's pretty simple. That's pretty simple to do. Let me show you. We're going to go into modeling mode. We're going to select all. Oh, you'll notice that the reason we haven't applied our array modifiers yet, so let's go back and do that. So for each, you want to apply them in the same order. So from top to bottom. Okay, so now that they're applied, we take this and let's frame that into view. And what we're going to do is we're going to go to front view. We're going to go into X-ray mode. And then what I'm going to do is we are going to box select the center portion now that we're in X-ray mode. So this is going to cut all the way through the cube. So when I grab these, go to mesh, delete vertices. So that cut a hole all the way through the cube. Now we're going to go to the top view. We're going to do the exact same thing. So we're just going to right click. Why that doesn't have. We're going to do delete vertices. So that got rid of that. And now we're going to go to the right view. And we're going to delete these. And by doing this, if we look at our model now, you see that we've cut a hole through the center and the left and the top. So now this is exactly what we were looking for. One more thing I can do is go into modeling mode, select everything, go to mesh, clean up, merge by distance. So that deletes all of the duplicate overlapping vertices. Now that we have this cube, this Menger sponge, exactly what we want, we can export this out into an FBX. I use the Unreal Blender to Unreal Engine plugin. Go check that out if you haven't done so already. So you would just select your item, hit export to Unreal Engine. Then when we get over to Unreal, here is the cube that we have imported. So now we have a static mesh. That's exactly what we were looking for. I'm going to take this static mesh, and in our blueprint, rather than dealing with the hierarchical instance static mesh and all of this logic that I showed you earlier, I simply put a static mesh object, a static mesh component. I set it to our static mesh that we just imported, set a material for that, and if you look in the viewport, here is our Menger sponge. If you drag that blueprint now into our world, you can see that I created a scene here, and in this scene, let me get rid of this. In this scene, you can see that I have created a series of the Menger sponges, and then I set the rotation on some of them so that when they rotate, I can control the rotation using the rotating movement inside the blueprint. And by doing this, I can create the environment that I want. So now that I have my scene put together, I used a sequencer to generate the following, and this is part of the movie that you saw at the beginning. I hope you enjoyed today's video. If you like this kind of content, please consider subscribing, and I hope you have a great day and a safe day. Bye.